The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. Thank you so much for joining us for our webinar today, How's the Water in the Hudson?, led by Riverkeeper's Water Quality Program Manager, Dan Shapley. My name is Dana Gully, and I'm Riverkeeper's Outreach and Volunteer Programs Manager. I just want to mention a couple of quick logistics items before we get started. First of all, this webinar is being recorded, and you will have access to the recorded version once we get it up on our website, either tomorrow or early next week. So please know, if you're taking notes, you will have access to a recorded version of this. We hope when we send it to you that you'll also share it with people in your network who might be interested. Secondly, all participants are currently on mute and will remain on mute. We will have time at the end for a question and answer session. So if at any point during the presentation you have a question, go ahead and on your webinar pane, there is a tab for questions, and you can type in your question at any point during the presentation, and then at the end we will get to as many questions as we can. So without further ado, I'm going to turn it over to Dan Shapley. Dan?
Thank you, Dana, and thank you all for joining us today. My name is Dan Shapley, and I am the Water Quality Program Manager for Riverkeeper, and I'm going to be walking you through some of the findings from our latest annual report about water quality in the Hudson River and its tributaries, Hudson River estuary, I should say, and its tributaries. We just put out this report earlier this week. You may have seen some press in the last couple of days about it. So this is a sort of more in-depth view about some of the findings. You can find this entire report on our website. There's a PDF version, and there's also a sort of magazine-style version on the website. So you can find both of those, and we'll send out around those links at some point during the presentation so you can find them. Okay, so today what we're going to talk about is describing first what we do, what these Riverkeeper studies are, some of the major findings from the period of time we've been studying this water quality issue, and then finally, and perhaps most importantly, what you can do as individuals to get involved and try and help us make improvements to the water quality and continue the restoration of the Hudson River that we've witnessed to date. The first point that we always like to make is that the Hudson River and its tributaries are our beach. There's swimming, kayaking, jet skiing, tubing, water skiing, all sorts of activities where you can come into contact with the water that are happening all throughout the estuary. And you see in this little snapshot different parts of the river and different parts of the watershed all being used for swimming and other activities that are relevant to this type of testing that we're doing. So what makes the water unsafe for swimming? What our findings, I'll give you a little preview. Most of the river, most of the time, we find water quality that's quite good for swimming. But there are still times and places where that is not the case. So in those cases, what is typically the cause is untreated sewage or other fecal contamination being in the water at levels that exceed federal guidelines. And when that happens, it means that there are pathogens in the water, such as viruses and bacteria and things that can cause illness. So when those are in the water, your risk of getting sick is increased from swimming. So it's not to say you're going to see a lot of data in the coming slides, and it's not to say that if the water is over the threshold set by the EPA that we're measuring against, it means you're definitely going to get sick if you happen to go swimming on that day, but it does mean your risk of getting sick is increasing. The types of illnesses that are typically looked at for this type of recreational exposure are typically like a stomach illness. It'll be something like a viral stomach flu is the most common. Nausea, diarrhea, vomiting. Those would be the typical symptoms. Things like eye and ear infections are also possible from this type of exposure. And there are much more serious illnesses that can result, and they are more rare. The most common, as I said, are more stomach-type illnesses. So where are we testing? We're testing since 2008 with our scientific partners at CUNY Queens and Lamont Doherty Earth Observatory, 74 different locations in the Hudson River estuary. That's from all around New York City all the way up to Waterford, New York, which is above the Troy Dam. In addition to that, we're studying many locations in tributaries and along the waterfront around New York City at public access points, and that's work that we do to support a number of partners, more than 80 sampling partners at this point, and more than 180 locations where we're testing over 250 miles of tributary streams. Oh, and all of this data, I should point out, is available on our website, so every single point tested, every test taken, the data is available publicly at that link below. This is just another view of the same thing. You can see this is what you'd find on our website right now. You can click on any one of those dots, see the latest test taken, what it showed, and see the history of samples taken at that location. So on the left you see the Hudson River estuary, and on the right you see the community science sampling projects, which are in the tributaries and all around New York City. How we test, we sample from our patrol boat. Riverkeeper has a boat on the water, and we also, as I said, work with many partners. So this is kind of what it looks like. There are specific protocols we follow, which I won't go into, but in its essence, it is dipping a bottle in the water and getting a good sample. What we're testing for is called Enterococcus. It's a family of bacteria that is not in and of itself harmful, typically, but it indicates that harmful pathogens may be in the water. Again, going back to that first slide about what can make you ill from exposure to this type of contamination. And we're using all EPA recommended methods, guidelines, and criteria, both to take our samples and to understand the results. So this is a look at what the cover of our report looks like, and what we are doing, we can confidently say, is the most extensive survey of its kind in the Hudson River estuary and its watershed, and we're very proud of that, and it's the most useful source of information for folks who want to go swimming and for a lot of the certain regulatory and infrastructure investment decisions. But it is not, I need to tell you, sufficient to tell you if it is safe to swim at the moment you want to swim, at the place you want to swim. So this is obviously the thing that we all want as people who go out in the river. This is the exact information you want. You want to know before you jump in, is that spot safe? And so I want you to know we cannot tell you. It's the question we get the most frequently, and there's just not enough data in order to do that. We have some recommendations. It's part of our action agenda to get us to that point, but at this point, there's just insufficient information to predict that at many locations. But we do know a lot about broad patterns that can help you make an educated choice, and that's what I'm going to talk about next. These are some of the swimmers for the 8 Bridges swim, which goes from the Rip Van Winkle Bridge up in near Hudson, New York, all the way down to the Verrazano Narrows Bridge in New York City. They swim the whole length of the river over the course of days, and they're an example of swimmers who have used our data to make educated choices about where they swim and where they choose to swim in our river. So the major findings, there's just 3 major things that I want to try to get you to take away from this talk. The first is that water quality varies. The second is that the contamination is often greater in tributaries. And the third, that rain often increases contamination. I'll go through them one by one. So water quality varies, and in more ways than one. It varies over time at all locations, and it varies from location to location in both frequency and degree. Now, the frequency and degree is important because the more frequently any spot is contaminated, the more likely you are to encounter contaminated water at that location when you jump in. The degree of contamination matters because the more contamination in the water, the greater your risk of getting ill from contact with that water. So they're both very important concepts to consider as we go through some of these stats. Most of what I'll be showing you is related to frequency of contamination, just to keep things digestible for our purposes today. So here's an example of one of the views of the data that you can see on our website. You can see this is a snapshot view of all of the samples taken at a particular location, in this case Kingston Point Beach, which is right near where I am talking to you from today. It's my local beach. So one thing that you can see here is that the contamination varies over time, and this is true not only at Kingston Point Beach, but every location. So there are days when we've tested, and I should tell you what this chart is showing. On the upright axis there is the level of contamination, of fecal contamination, and it's a logarithmic scale, which only means that you can see at the very top we're all the way up to 10,000, whereas halfway down you're already at 100. So as you go up, you're actually seeing much higher levels of contamination as you climb that scale than it looks when you first glance at it. Along the horizontal axis is rainfall, so the amount of rain that's fallen cumulatively over the last 3 days prior to our sample. And so what you see here is that you have many times when you've had water quality that has met the federal guideline for safe swimming. Those are the green dots, and you do have some times when it has exceeded that level. And you can see that on any given day you might be in one of these different locations. You might be in a green or in a red. So if you compare that to another site that's very close by, just about a mile away, the Rondout Creek public dock, and you see that the contamination at these two locations varies significantly between the two of them in both frequency and degree. So to visually just point that out, you see a lot more red dots, so more frequent contamination at the public dock on the Rondout Creek. And to contrast also that green circle, you see an absence in the Rondout Creek side of the very low levels of contamination, the lowest readings on the scale, and overall many more green dots at the public beach. So as you're looking at our website, this is one way to make a choice about where to swim. You can say, well, there's less frequent contamination at Kingston Point Beach, and there's also, when it is contaminated, it is infrequently at a high level, whereas at the public dock is higher levels of contamination, more frequent contamination, and also can be at higher levels we've observed there. And that's important because people swim all over. Again, just to underscore that point, this is a picture of people swimming right at that public dock in Kingston. So go on to the next major finding. Contamination is often greater in tributaries, which underscores also the last point I showed you with that data. It's important to note that contamination varies quite a bit from tributary to tributary, though, so not every creek is equal. Here's a basic look at the overall data for our core study of the Hudson River. This is showing the frequency of contamination out in the middle of the river. And you can see 18% of those the safe swimming guidelines recommended by the EPA. Over the locations where we're testing new shoreline taken in tidal tributaries. The frequency of contamination varies quite a bit from tributary to tributary. So you see more infrequent contamination in the Catskill Creek and Esopus Creek as compared to the Wallkill and the Sparkill, for instance. And this data that you're seeing here is for the non-tidal tributaries. So this is data that's gathered by our community science partners out in the tributaries. Okay, so the final point I want you to take away from today is that rain often increases contamination, and in some places more than others. Overall, all of our samples in the Hudson River estuary, this is 12% of them failed to meet that federal guideline for safe swimming. After rain, 35% though. So I'm sorry, I should say dry weather was 12% and wet weather was 35%. So you see the frequency increased quite a bit. But you'll see in the next series of charts that it's quite different based on the type of location. So again, out in the middle of the river, the mid-channel, you see a quite low failure rate in dry weather, and this compares favorably to beaches nationwide, where it's about a 10% failure rate of this EPA benchmark for safe swimming at public beaches nationwide. So the middle of the river fares very well compared to the nation as a whole. But in wet weather, it does jump up quite a bit. Again, at the shoreline, 10% failure rate is quite similar to what we see nationwide at beaches overall, but in wet weather, it jumps up significantly. And finally, in the tidal portions of tributaries, we start with a higher frequency of failure to begin with, and then it jumps up dramatically in wet weather. And we see that played out similarly in the non-tidal portions of the tributaries, where we have a much higher frequency of contamination and higher degree of contamination after rain. So, to move on to what you can do here for a couple minutes before I take questions. Excuse me again. First of all is think about how you are managing your own toilet, frankly. Don't flush anything but toilet paper. We're seeing millions of dollars of damages and frequent sewer overflows triggered by particularly these flushable wipes that are not really flushable. They're labeled flushable, but they aren't flushable. So this is something that is gumming up sewers and pump stations around the region and around the country. They also can wreak havoc on a septic system, so they're best avoided. It's important to take responsibility for that. If you have a septic system, it's very important that you do inspect and pump it out regularly. And then finally, conserve water and take responsibility for your own streets where you might have a storm drain that's draining storm water into hopefully into storm drains, or possibly if you're in one of our cities, that it might be draining into the sewers themselves. And those combined sewer systems have a big impact on some of the data I showed you earlier on the influence of rain on our water quality. In addition, we urge everyone who can to get involved with a local water protection effort. We have a lot of really great groups throughout the Hudson River Valley who are doing work in their watersheds. Almost all of them need more volunteers and more people supporting them, so consider doing that or helping out with your town's Conservation Advisory Council. We will be sending around links that will help you sign up to receive Riverkeeper emails and also sign up for the Sewage Pollution Right to Know alerts. And this is a law that was passed in 2012 at the urging of Riverkeeper and provides the public with the first real-time alerts for when there's a known sewage discharge of untreated or partially treated waste. So at least you'll have an idea of where and when certain releases happen so they can be avoided if you're a swimmer or a kayaker. It's important to note with those that it's not, the absence of an alert does not mean clean water necessarily, but at least it will tell you where you can avoid. And finally, we urge you to volunteer. Riverkeeper organizes an event each spring called the Riverkeeper Sweep, where we clean shorelines, plant trees, and take part in other activities to help our creeks and our shorelines. That's one great opportunity, but there are a lot of others. It's really a dramatic effect when people get involved in even small ways. So finally, we urge you to get active, and with the release of our report, we're making two strong focused calls that we'll be repeating over the next couple months, and that is to tell the governor and your state and state Senate and Assembly members that, one, you value clean water, and two, that you want to see this $800 million annual gap in wastewater spending closed. That's what the New York State Comptroller identified as the difference between the expense that we have documented that we know we need to spend to shore up our sewers and the amount we're actually spending. So there's 800 million in need that's going unmet each year as of his last report. This translates into overflows of sewage, it translates into contaminated water, and we need to commit the money to do that work. And because it's a big dollar amount, the governor and the legislature need to know that people value it and that they want that done. So we're asking you to tell your representatives that you value it and you do want that work done. And we also really want to see the DEC staff increased. There's been a 30% cut in staff to the Division of Water, particularly over almost 25 years, and we want to see that staff restored so that the Division of Water and other key elements in the Department of Environmental Conservation can do the work that we want them to do, which is to enforce our environmental laws and clean up the water. Finally, the sewage pollution right to know law that I mentioned is currently the regulations are being considered. They're draft regulations rather, and the public has a chance until July 31st to comment on these. So we urge you to learn about these. Go to Riverkeeper website. We will be putting out specific information about how we think these regulations could be changed, and what we would urge you to say. But overall, we want you to just tell the DEC what type of information you need and want to use the water safely, and make sure that your opinion is known. There are 3 public information sessions coming up, and we have information about each of them on our website, and there'll be a link sent around so you can find one that's closest to you so you can learn more about the law and make informed comments before that deadline of July 31st. And finally, we are a nonprofit organization, so if you value this work that I've described here, please consider making a donation to become a member. It supports activities such as in this photo. This is a photo from our Riverkeeper sweep from 2 years ago where this gentleman cleaned up the Wappinger Creek in a quite dramatic way. So I want to thank many of those who have funded this work. I won't list them all, but there are many individuals and foundations and even a couple of government agencies that have paid for some of this work over the last year and over the years that it's been ongoing. And I want to thank the other members of the team that I work with, both in Riverkeeper and at our university partners, and the many organizations and individuals and advisory boards that contribute to this project by taking samples, and they are all listed, many of them here. And with that, I will take some questions, and I think there are already some questions that have been posed, so let me take a look at those. Okay, so one question. How is the Hudson doing in Albany since the spill in Fort Edward? So there was, through the sewage pollution right to know law, identified I think it was 1.2 million gallon discharge of sewage that wasn't completely treated from the Fort Edward area. And that went directly into the Hudson River, and it was written about in the Glens Falls Post-Star. I would imagine the impact to the river specifically is probably undetectable at this point. It's been a week or 10 days since it happened, but that plant is in a category of failing plants. Has frequently violated its permit limits, and it's not alone in that. There are many plants around the region and state that are in that state, and that's one of the reasons that we're calling for increased staffing to the DEC, because the DEC needs more resources to be able to enforce our environmental laws and get those plants into shape. And it's also the reason why we're calling for more investment dollars into our sewage infrastructure, because there are expensive fixes to stop that type of overflow and discharge. All right, another question. Dots on the water quality chart don't appear correlated with rain in the Kingston area. Why not? Let's go back to those charts so we can look at that a little bit. Okay, so I would say that you actually do see quite a bit of rain correlation on the Kingston Point Beach side, and this is one place you can see when there's been zero rain, when they're right on the y-axis, there are no exceedances of the EPA's guideline for safe swimming. So the Kingston Point Beach is, if there hasn't been rain, there's a very good chance that you're going to encounter good water quality there. There is, as you can see, even after a little bit of rain, there have been a couple of times when it's exceeded that benchmark when we've sampled. So it's not, so it is there, but there is a stronger correlation as you get more rain over the course of several days prior to a sample. So there does seem to be a rain correlation there. At the Rondout Creek public dock, there's also seemingly some correlation in that you have higher, the degree of contamination seems higher, more likely to be higher when you've had more rain previously, but there are instances where you've had poor water quality even in dry weather. So when you see that, that's an indication that there might be some kind of infrastructure failure or some other issue in that area that needs to be addressed. I don't have any specific guess as to what that might be here in Kingston. We did see, we had a case in Newburgh where we had a similar situation where we saw at the public dock there relatively frequent exceedances of this benchmark in dry weather, and the city ended up finding a number of sewer lines from buildings that were connected to the storm sewer and were discharging into the river in dry weather. So that is has happened elsewhere, and when you see these dry weather problems, it's an indication to me that investigation is needed to see if there are any infrastructure failures. Let's see, another question. Have you tested the following hypothesis? Rainfall significantly increases the bad stuff in non-tidal sections of the tributaries, but not in the tidal section of the tributaries and the Hudson. So we see overall rain increasing levels of contamination. It is, as I indicated in some of the charts, uneven in its impact. So the impact is greater in tributaries than in the mid-channel of the river. And if you look at the more deeply into the increased contamination in the mid-channel, the increases are heavily skewed toward the capital district in near Albany. So that's where the river's a little narrower, and you have tremendous sewage inputs during rain from combined sewers in that part of the river. So outside of the capital district, in the middle of the river, we see very, very infrequent contamination even after rain in many places. So that gets to that question a little bit. We do see a great, you know, there's a if they're proximate to communities, but less so if they're near forested shorelines. Surprising, given that the likely causes of contamination would be sewage overflows, sewage infrastructure failures, or stormwater, or some combination of those. Okay, question, without finger pointing, major culprits along various stretches of the river. Okay, so I mentioned, and there's a big section in the report on this, on potential sources. I urge you to check it out. But combined sewer overflows, we know, are an obvious source. They're a known source. So that these are, again, systems of sewers that are combined with stormwater systems. So the same pipes carry our sewage and carry our stormwater that runs off the streets or street water, as we like to call it. So in the Capital District, on down to City of Hudson, the village of Catskill, City of Kingston, City of Poughkeepsie and Newburgh, and several communities in Westchester County, and of course New York City and northern New Jersey communities. There are many combined sewers, so we know that those are discharging in wet weather when there's enough rainfall, and it's a different amount in different communities that triggers the overflows. There are long-term plans being put in place by the DEC to reduce this contamination. We are always advocating for strong plans in that respect to reduce the contamination and the overflows as much as possible. In addition to those, there's something when even separate systems, so plants that are only trying to, or pipes that are only carrying sewage rather, when they reach the plant, sometimes even in wet weather, rain can infiltrate those pipes and cause overflows once the water gets, or all that sewage and stormwater gets to the plant, because the plant can't handle that much flow. So sometimes that can result in untreated or partially treated sewage discharges. Stormwater itself can carry fecal indicating bacteria that we measure, so even the storm sewers and the runoff from streets, if you imagine dog waste that you might have seen left on the street, or as one source of that type of contamination. And then finally, as you get into the tributaries, there probably other sources in certain places where there are, it could be failing septic systems at individual homes that might be contributing to some of the contamination we're measuring. And certainly I think in some areas there's agricultural runoff. So if manure is being spread as a fertilizer, or if livestock is not being kept out of streams, those would be contributors to the pollution that we're measuring with these studies. Let's see, another question. Can you speak about the impact of cleanup of PCBs by GE and what might still be needed to fully restore the river after the Superfund cleanup is complete? Okay, so it's not my direct area of expertise, but I'll try to address some of the bigger points. The cleanup of PCBs in the upper Hudson, this is about 40 miles north of Albany, where they were discharged from capacitor manufacturing plants for decades, and PCBs are an oil and they tend to stick in the mud. So the solution that was agreed to and which we advocated for was to dredge the contamination. That's the project is nearing its end. GE has done the job and done it well. One of the things that I remember the Riverkeeper Sean Cronin, the former Riverkeeper, used to say is, you know, GE has the smartest engineers in the world. If you put their minds to it, they will do a good job, and that seems to be what has happened. However, there are a lot of areas of contamination that weren't targeted for cleanup, so we are advocating to get those last as much of the contamination out now while all the infrastructure for dredging is in place. There's an active campaign going for that, and maybe Dana can send around the link to that campaign so that people can get informed about it and get active on it. In addition, you know, taking that toxic contamination out of the river is hugely important for getting our fish back to a point where we might be able to eat them. But there's a host of restoration projects that could be done in the Hudson River, and there's an active planning process to try to identify them and start to qualify for federal funding for them, and also to, I think, channel some of the next phase of damage of the PCB cleanup is to identify natural resources that have been damaged and how they can be restored. So there'll be a process to go through that. There are many things. I mean, just to name one, there are hundreds of acres of shallow water habitat lost in the upper Hudson that was prime spawning habitat for herring and shad. That's been lost over, you know, decades or more than a century as we've dredged the channel and altered the shoreline. So there's opportunities to restore some of that habitat that could have a lot of benefits for the river and for fish. So let's see, moving on to another question. could it be that exceeding the concentrations in the river in dry weather is due to the infiltration of groundwater into the sewer? The sewer might be damaged and the groundwater might enter and determine and cause overflows. So we do suspect that that might be an issue in certain places, particularly in some creeks. It's one of the concerns and issues we've are exploring and want to see really investigated much more actively in the Sparkill Creek, where you have a lot of sewered areas, older sewers, and our suspicion is that many of them are leaking into the groundwater and then infiltrating the creek. But we don't have evidence of that. It's a hypothesis. It's a question we want to see explored and answered. So yeah, that is definitely one concern and one area for further research and inquiry. Are there any other questions? We have a couple more minutes. People are welcome to stay on the line. I'll stay on the line, and if people have other questions, I'd be happy to answer them. Maybe I will pull up the report itself so you can see some of the figures that are in there. Maybe it'll trigger some other questions. So in the report, you will find a full view of all of the data for the Hudson River sampling points that we've been taking, and you'll see the chart that you'll be familiar with after having seen it on our some of the charts I showed earlier on the left, and then there's another number of other figures that are explained in the report that are more long-term measures of water quality that are very significant, but you can delve into if you want to read the report. And I do have another question. Does any aquatic vegetation reduce the bad stuff? That is something I don't know the answer to. I know there are floating wetlands beds that have been developed in some areas that I believe they're designed to remove nutrients primarily, more than bacteria from the water, and my suspicion is that that would be much more likely to be effective than some kind of specific vegetation to remove bacterial contamination that we're talking about, fecal indicating contamination. But there is an active area, one of the areas that we need to research more, we collectively, the scientific community, is how the fecal contamination we're measuring interacts with sediment and how long-lived some of the fecal indicating bacteria might be in tributaries particularly. So there's a lot of areas for further research, and I would add this to the list. And then another question, do any animal species like fish, snails, or bugs reduce the bad stuff? And again, not that I'm aware of, but that does not mean there are none. As I wait for more potential questions, I'll just show you a couple other things you can see in the report, and maybe we'll So here you'll see each tributary that we're measuring has a map and all of the data for it. Again, you can also find this on the website, and maybe I'll just show you quickly how you can find that information. So if you're at riverkeeper.org and you go, so you're at the home page, you click on water quality here at the top, and you can either choose Hudson River data or citizen testing data. The Hudson River data is for the estuary. And as I described before, you can click on any particular point see the latest results, see how much rain there was prior to that result, and go directly in to see all of the data for that site. And it's ordered in order of the latest test, but you can also sort by to see the lowest or the highest counts recorded there. You can sort by rainfall if you want to try and learn something more in depth about some of the locations you're interested in. And you can find that graph that I showed for the Kingston sites by clicking up here. This tab will show you the information for each site at a glance. Okay, so there haven't been any more questions. I want to thank everyone for joining us, and please follow some of the links that Dana sent around, and I want to thank Dana also for organizing this, and with that we'll conclude the webinar.